Okay, so we left off right here when we were taking the inverse of this matrix times this matrix, which will give us our answer. Okay, and I was just expressing how, the order does matter. Okay, we have to do the inverse times this, so that you have a 2 by 2 times a 2 by 1. Okay, so let me just show you. I already put this in my calculator. Okay. So in other words, my matrix A, if you want to look at it, is 3, 2, 4, negative 1. That's this one. Okay. My matrix B is, matrix B is 1, negative 6. Okay. Which is this one. So for me to solve this equation, I am going to take matrix A. I want to do the inverse of that times my matrix B. Okay. And when I do that, I get, negative 1, 2. So that means that X, my answer was negative 1, 2. And we talked about in, 6, 2, what this means when two matrices are equal. This means that X equals negative 1 and Y equals 2. Realize that this matrix equation can be written as a system of equations. 3x plus 2y equals 1. And 4x minus y equals negative 6. So let's see, if x is negative 1, that's negative 3 plus, if y is 2, 2 times 2 is 4. Does negative 3 plus 4 equal 1? Yep. 4 times negative 1 is negative 4 minus 2. Yep, that's negative 6. So again, I usually check. Okay, now we've solved systems of equations. I know that. You did that whole RREF, reduced row, echelon form worksheet for me. So you could have solved this that way as well. I get that. Okay, and I don't care which way you do it. You could have made, in other words, you would have made this 3, 2, 1, 4, negative 1, negative 6. You would have made this equation a 2 by 3. Okay, let's do that on our calculator. We'll enter that as matrix C. Okay. Let's enter matrix C, whoopsies, and call that, what is that, a 2 by 3? 2 by 3, and let's enter those numbers, 3, 2, 1, and the second row is 4, negative 1, and negative 6. Okay, I'll quit out of that and then go back in and say, hey, I want to do some math with what is it? I went down to RREF is what we did before, and I'd like to do that with matrix C. Okay, and that'll give me, x is negative 1, y is 2. See it? Remember? Okay, these are two different ways to use your calculator to solve a system. Okay? Let's do a harder one. Okay, let's just go right to here. All right. What I would do, if I'm going to do the new way, okay, I'm going to write it as a matrix equation. Okay, the matrix equation would be 2, negative 1, 3, 4, 2, negative 6, negative 1, 1/2, negative 3. That's 0.5. So I just wrote a half. I don't know, whatever. And then times, my variables are x, y, and z, equals 8, negative 12, negative 3. That's how I write a matrix equation from a system. And now I realize that to get x, y, z alone, I'm going to have to multiply by the inverse of this matrix. So to solve, sorry, I'm having some problems again. No, what? Everything's on top of each other. Okay. Okay. To solve this, I'm going to take 2, -1, 3, 4, 2, -6, -1, 1/2, -3. I'm going to take the inverse of that times 8, -12, -3. Okay, and that's going to be the answer to X, Y, Z. Okay. Sure. Here. So X, Y, Z equals this inverse of this matrix times that. So for that, I'm going to pull up my calculator. I'm going to enter a new matrix. Let's edit matrix A so that it's a 3 by 3. Okay. Matrix A, 3 by 3. Now I have to enter these numbers. It's 2. Okay, 2, enter. -1, enter. 3, 2, -1, 3. I'm just entering the numbers here. 4, enter. 2, -6. -1, 1/2, and -3. Okay, there's my matrix A. And then I also have to enter matrix, let's do B. I'm going to edit matrix B and change that into A. Let's see, this is 3 rows and 1 column. A 3 by 1. Okay, and let's see, what are they? 8, -12, and -3. Okay, so what I want to do now that I have my matrices entered, I have to take A inverse times B. So I go second matrix. I want A first. I want to take the inverse of that. That's right here, x to the -1. I want to take A inverse times matrix B. Okay, a 3 by 3 times a 3 by 1 will give me my 3 by 1. Ooh. Hey guys, you can do math enter if you get a fraction. Or if you get a repeating decimal like that. There we go. So I have x is a half, y is -9, and z is -2/3. Okay? Is the final answer. X, Y, Z equals a half, 9, 2/3. Or whatever it was. A half, -9, -2/3. There. X equals a half, Y equals -9, Z equals -2/3. I, of course, would try it just to make sure. 2 times a half minus -9 plus 3 times -2/3. Let's see, 2 times a half is 1 plus 9 minus 2. So that's 10 minus 2. Yep, that's 8. Sometimes I just check the first one and I assume that I did it right then. But if I really wanted to, I would check them all. All right, so you get a half, -9, 2/3. I just want to show you the way we used to do it. Okay, if you wanted to do this the REF way, then I'd go 2, -1, 3, 8, 4, 2, -6, -12, -1, a half, -3, -3. I'd enter this 3 by 4 matrix, and I'd do the RREF. Okay, so it would just mean entering another matrix, perhaps C, and, okay, sorry, entering another matrix. Let's edit matrix C. I forgot to go to edit. And we want it to be a 3 by 4 this time. And we're going to have, I know I'm so slow at this, 2, -1. It lets you have time to enter it as well. 2, -1, 3, 8. You can't see over there. That bothers me, but oh well. 4, 2, -6. Oh, that's already -6. -12. Wait, I still want that to be -6. And then -12. And then we have -1.5, -3, and -3. Okay. We'll quit out of that, and then we'll go back in and say, let's do some math. Let's do the, we'll do some math with row reduced echelon form with matrix C. And what a shocker. We got 0.5, -9, and -2/3. I want to go math, enter to change that to a fraction. There, 1/2, -9, -2/3 with our identity matrix here. So I know X is that, Y is -9, Z is -2/3. Okay? Those are the 2 ways. Okay, there's one more thing that I think I should mention. That's the determinant of a matrix will tell you whether or not the matrix has an inverse. Sometimes the matrix is not invertible, which then means you're not going to be able to find a solution anyway to that equation. You know how we had no solution sometimes to our problems? Determinant, let's go to matrix math. It's the very first option. That's determinant. If I wanted to find the determinant of matrix C, or matrix A, since I'm there, the determinant of matrix A, you can only find the determinant if it's square. So 2 by 2, 3 by 3, 4 by 4. Okay, the determinant of matrix A is -12. Okay, that tells me I can find the inverse of it. If the determinant is 0, then you're like, oh, cannot find the inverse, so I might as well not even try to solve this problem. It will have no solution. All right, so I put that in there because just in case they reference that in the final, and we'll have some practice problems. It's one number that goes with a matrix that tells you whether or not you can find the inverse, or that you can find the inverse, okay, if it's invertible. All right, gang. Practice, come to class, of course, and come to the office hours. We're getting there, all right? Next, our final will be December 11th, and we'll be good. All right, talk to you later. Have a good night. Bye-bye.